show that dou f by dou x and dou f by dou y exist, but f is not differentiable at 0 0. Correct? Did you complete that? See, it is easy to show this is not differentiable at 0 0. Why? If you remember, in the starting only, in the continuity part, I have proved this function is not continuous by putting y equal to mx. If you put y equal to mx, I'll do it here maybe for you. See, f of xy, that is equal to given as 2xy upon x square plus y square. What I am going to do, putting y equal to mx, so the limit will be only with the x, that is limit extending to 0. It will be 2, it will be mx square upon x square plus m square x square. That means what, this is 2m upon 1 plus m square. Correct? That means for different value of m I am having different value, different limit. Correct? But since limit exists, so the function is not continuous. That means what, f of xy is not continuous at 0 0. Correct? Because if a function is continuous at a point, then if we take any path, the function must be continuous. Correct? But if I'm putting this path, then for different value of m I will be getting different limit. But we have proved that if limit exists, then limit must be unique. So this that means function is not continuous. Agreed? So the function is not continuous implies function is not differentiable. Not differentiable at 0 0. So we have proved the first part, that is function is not differentiable at 0 0. Now I'll prove that fx and fy exist. Now what is definition for fx? See, dou f by dou x, that is equal to limit uh, x comma y, sorry, it will be h tending to 0, limit h tending to 0 f of 0 plus h comma 0 minus f of 0 0 and divided by h. What is that? Limit h tending to 0, put it in the formula. At the place of x you have to put h, so it will be, I think, uh, this will be 0, man. Y into 0, so this will be 0 minus 0, that is 0. Correct? Dou f by dou y, that is equal to limit k tending to 0 f of 0 comma k minus f of 0 0 divided by k. What is that? Again, do you see that this is 0 and k? So if you put at the place of x, if you put 0 and k, it will be again 0, so it will be 0 minus 0. Correct? That is 0. So fx and fy exist and still the function is not differentiable. Correct? So main, what was the motto to ask about this question? In the earlier question, partial derivative does not exist. What did I say? F is not differentiable. But if partial derivative exists, then also it is not differentiable. Do you see? Partial derivative exists, then also it is not. So I need a sufficient condition which can tell me that the function is differentiable. So that is the sufficient condition of differentiability. Of sufficient condition for differentiability. See, you remember this theorem because we'll be doing this theorem, we will be using this theorem in your SyBsc also. I'll just read the theorem first. Let U subset of R2 be an open set and F from U to R be a scalar field. Suppose dou f by dou x and dou f by dou y exist and are continuous. are continuous at E1 E2 which belongs to U, then f is differentiable at E1 E2. Correct? So the do you see the extra condition? Partial derivative must exist and must be continuous. If I write in the this form fx and fy must be exist and continuous, implies this is actually if and only if f is differentiable at A1 A2. Correct? This is what sufficient condition for differentiability. Yeah, you don't have to write this implies this. That is easily follows. If f is differential, then fx fy exist and they must be continuous also. So it is just make in this statement we are going to prove this one. Correct? If fx and fy exist and continuous, then we will say f is differentiable at A1 A2. Correct? Let us try to prove this. This is most important theorem. You will be using it everywhere. Okay. So what we have to prove f is differential at A1 A2. We are given fx fy exists. So let us start. I will change the color. Maybe I am using from last 2 3 days. Yeah. What is given? Given fx and fy exist and continuous. Let h equal to tu be such that p belongs to r and now mu, that is unit vector, that is equal to 1 u1 u2 and that is equal to 1. Okay, what do I have to consider? Consider this f of e plus h minus f of e. करेक्ट, जैसे हम लोग पहले लिखते थे सेम थिंग. सो व्हाट इज h फॉर मी? दिस इज f of e plus tu minus f of e. That means what if I write it in coordinate wise? It will be f of e1 plus tu1 comma e2 plus tu2 minus f of e1 e2. Correct, but I want to relate it with partial derivative. So what I will do now, I'll add and subtract something. What that? That is f of e1 plus tu1 as it is and e2 plus tu2 as it is. I'll subtract with f of e1 plus tu1 comma e2 and I'll add that f of e1 plus tu1 comma e2. Add and subtract and minus f of e1 e2. You will see what is use of this now. You know something, since fy is continuous at e1 e2 and even fy exists also, and fy fy at this point e1 plus tu1 comma e2 exist. Correct? Fy is continuous at e1 e2 and fy of e1 plus tu1 comma e2 exist. So what is use of this? That means what if I want to find fy of this, then what will be the value? Let us see. I want to find this fy at e1 plus tu1 comma e2, that is equal to dou f by dou y at e1 plus tu1 comma e2. What do you mean by that? What is the formula? That means limit there will be another guy, say tu2 बोलता हूँ मैं, tu2 tend to 0. The function will be f of e1 plus tu1. X coordinate will be x as it is, y coordinate will be this e2 plus tu2 minus the same thing right here, minus f of e1 plus tu1 comma e2. and that divided by 2. That was the this was the definition of partial derivative. I hope you remember that, correct? What next? Now I have got this formula. Let us do one thing. Can I make everything aside? That means fy I keep that side. That means what? If I write like this, that is limit tu2 tend to 0 f of e1 plus tu1 comma e2 plus tu2 minus f of e1 plus tu1 comma e2 upon tu2 minus fy of e1 plus tu1 comma e2, that is equal to 0. I am keeping this guy in the left hand, in the right hand side only, and writing this term that is equal to 0, correct? Now what I am doing, I am going to consider this guy as a function u. I want to assume this as u, sorry, e, error function, that is called e of e1 plus tu1 comma e2, that is equal to this whole term, that is limit t tu2 tend to 0. No, sorry, I'll not put limit. I'll, this will be just f of e1 plus tu1 comma e2 plus tu2 minus f of e1 plus tu1 comma e2, and divide by tu2 minus fy of e1 plus tu1 comma e2. And what do you observe, as tu2 as t tending to 0, what will you have? E of e1 plus tu1 comma e2, this goes to 0 as t tends to 0, correct? I'm considering this whole part except that limit, this whole part I'm putting as e of et1 tu1 comma e2, and as t goes to 0 this will go to 0. That is easy, correct? And what do you observe, if you solve it little bit, you solve this thing little bit, that means if I want to get the value of this, correct? So I if I multiply tu2 with everybody, then what will I get in this? Okay, I'll get this. Mm, f of e1 plus tu1 comma e2 plus tu2 minus f of e1 plus tu1 comma e2 minus, it will be fy of e1 plus tu1 comma e2 multiply by tu2, that is equal to e of e1 e1 plus tu1 comma e2 multiply by tu2. Do you see, I'm just multiplying my tu2 everywhere, so here it will be tu2 and here with fy it will be tu2. That's it, correct? Okay, now do you see whatever I have done with dx, similarly can I do with dy? That means whatever I have done till now, the same thing I'm going to do with dy. D I actually sorry, I did for fy. I did everything for fy. Correct. Look at this page, whole page. I have done everything for fy. Similarly, I'm going to do for fx. I'll change the color so that you get that. Further, do f by do x at e1 e2 exist. Same thing. That means what? Do f by do x at e1 e2. What is the formula? What is the formula? That is limit tu1 goes to 0 f of e1 comma t, sorry, e1 plus this is x coordinate, e1 plus tu1 comma e2 minus f of e1 e2, correct? And that divided by tu1. And what else, उस बार क्या किया था हम लोगों ने, take everything aside, then दिस विल बी, इसको शॉर्टकट में ही लिखता हूँ मैं. सो दिस विल बी लिमिट टी यू वन गोज टू ज़ीरो एफ ऑफ ई वन प्लस टी यू वन comma e2 minus f of e1 e2 divided by t u1 minus fx at e1 e2, correct. That is equal to zero. And next step इसको हम लोग g consider करेंगे. Let g of e1 e2 that is equal to the whole thing except that limit जैसा उधर किया था, f of e1 plus t u1 comma e2 minus f of e1 e2 and divide by t u1 and minus this term fx at e1 e2, correct. And what is the condition? G of e1 e2 goes to 0 as g of e1 e2 goes to 0 as t goes to 0. Same thing जैसे पीछे किया था, पिछले में किया था वैसा ही, correct. Now observe, here also will multiply t u1 both the side. I'll put this as equation number e. You can take the whole thing is equation e. You can consider, and here after multiplying I'll put it as equation 2. So if I multiply t e1, I'll be having this f of e1 plus t u1 comma e2 minus f of e1 e2, that is equal to what? Oh sorry, minus fx at e1 e2 multiplied by t u1 this is one. That is equal to g of e1 e2 multiplied by t u1, correct. I'll put this thing as b. Okay, yeah. Now I would like to relate with this. I would like to do differentiability na. So to prove the function is differentiable, what I need to prove function is differentiable, I need to define t of u, correct. That is, I need to define a linear transformation. So I'll define this linear transformation. Define t of u equal to, I'll change the color. Define t of u equal to u1 dou f by dou x at e1 e2 plus u2 dou f by dou y at e1 e2. And if you ask how did you get this idea that this will be this only, then go back and see how it was related. Maybe I had done some problem also. Yeah, look at this. Partial derivative, that is directional derivative of this is equal to t of u, and t of u क्या रहता है? This is u1 e plus u2 b, and what is e and b? E and b are the, and if you relate this as this is del f at u, del f at u, correct. So you just need to find del f and u. That is where, from where we got this idea that we can define t of u as this. So if I define t of u as this, what next I have to see? I have to put it in the formula first. Let us see what is t of h. T of h क्या रहेगा? Since t of h is equal to t of tu, and that is equal to t constant t of u. So that is okay. Now let us consideration part. Consider, what do I have to consider? Yes, what do you want to consider? The formula f of e plus h minus f of e minus t of h upon norm h, correct. This was the formula, correct. Now let us solve के लिए t of h का वैल्यू पता है. So this is mod of f of e plus h minus f of e T of h is t into t of u, and you know the formula for t of u also, correct? So I'll write it quickly. Minus t times t of u, and what is norm h? Norm h will be just mod t, correct? Norm u is 1, correct? And now if you take this, see, this thing is positive, that means if I take limit, then I can say this thing is 0 is less than equal to limit uh, h tending to 0, sorry t, now I'll be having, or, I'll just write mod of f of e plus h minus f of e minus t of h upon norm h, correct? And इसका वैल्यू हम लोग ने इधर फाइंड आउट किया. What is the value? The value of this is this. I'll put it here. So this is equal to what? Limit t tending to 0. It will be f of e plus h minus f of e minus t into t of u, and divided by mod t. This is what I am having, correct? Now what you have to do? You have to put the value of t of u. T of u का वैल्यू क्या है? पुट करते फटाफट. And write e plus h and f of a क्या है? Let us put everything. Limit t tending to 0. What is mod of f of e plus h? It will be f of e1 plus t u1 comma e2 plus t u2 minus e plus h minus f of a. No? This will be minus f of e1 plus t u1 comma e2, and I'm adding and subtracting this part, okay? F of e1 plus t u1, sorry, t u1 comma a2. I'm adding and subtracting this part, minus f of e as it is. If you want to write f of e1 e2, you can write, okay? And what is minus t into t of u, correct? So t of u क्या था? It was u1, so it will be t u1 fx at y e1 e2 minus t u2 fy at e1 e2, correct? And that is mod here and divide by mod t, okay? Now if you solve this, हम लोग ने e किसी को बोला है and किसी को g बोला है. If you observe from e and b, what is e and what is b? Look at this. This whole part I can write it as e of t u2, correct? Let us see, ye and fy, that means these three terms, ye and even this one also, na? And yes, this one also, and fy, these three people will form e of it. I'll write it, yeah. Limit t tending to 0, mod of this will be e of e1 plus t u1 comma e2 multiply by t u2 plus the remaining part will be g of e1 e2 t u. You can observe the remaining part is b. You are remaining with this thing, this whole thing, left hand side. I will be having g t u2 divided by mod t. You may write here from a and b, correct? What do you know next? Can I take t common? T is both the sides, so I can take t common. So what I will be having? I will be having this as limit t tending to 0. It will be just e of e1 plus t u1 comma u2 multiply by u2 plus g of a1 comma e2 multiply by u1, correct? This is mod. Can I use less than equal to limit t tending to 0? This is mod u2. This is e of e1 plus t u1 comma e2 plus it will be limit t tending to 0 mod u1 mod of g of e1 a2, and you already know what is this. This is again less than equal to 0 plus 0, correct? That means in the start you wrote this guy. Do you see? I'm going to do sandwich theorem. 0 is less than equal to this whole term, and this whole term is again less than 0. So what is my conclusion? Implies limit is tending to 0 f of e plus h minus f of e minus t of h upon norm h, that goes to 0, that is equal to 0. What do you mean by that? Implies f is differentiable at e, and df of e equal to t is given by, what is the formula? T of h is equal to h1 fx plus h2 fy, correct? Yeah, is proved. So let us quickly go back. See, जो भी हम लोग ने पहले u के साथ किया, that is fy के साथ किया, we could have done with fx also. Just the thing is we have to make, try to see this part. Main is this thing. I want to relate it with partial derivative, तो मुझे फर्स्ट स्टेप इंट्रोड्यूस क्या करना होगा, u. So इंट्रोड्यूस हम लोग ने कैसे किया वो, I started from this h equal to tu I started, and then I defined norm of u is unit vector, u is the unit one. Then I see f of a plus h minus f of लिया तो ये आएगा, and this. Then I see from here I want to relate it with fy. So I see this term and this term, and you see this is forming ux. This is partial derivative with respect to x, and this is forming uy, because here this guy and this guy is same. The changes is in y coordinate. Then from here I saw that since fy is continuous at e1 a2 and fy exists, so what do you mean by that? Fy at e1 plus t1 comma e2 exists. That means I want to relate this guy with fy. Do you understand? These two things are same for me. The variable is in y coordinate, so this will be fy. For this I am going to use fy, and for this I am going to use fx. So that is my claim. So I started. What is the definition of fy at this point? This is this, and later I put this as e of this and just cross multiply. I got this part जो मुझे यहाँ पे चाहिए था. I wanted this part ना. So that is why get, that is what I am having. This is equal to this I am having, correct? Further I am writing fx का definition same. My logic was this. I want to relate it with this, so fx का definition I wrote. So I'm having fx again, just multiplying by this, and I'll be having this next in the next line. I'll be having b. Now I will be defining t of u. It is u1 fx plus u2 fy. This is the main step. Then t of h equal to t of tu, that is equal to, since it is transform linear transformation, I can take t common. If I take t common, it is t of u, and consider mod of f of p plus h minus of h. This is my consideration part. You already know that. And at the place of h, I'll be putting tu. So it will be like this. Now let us see this whole mod part. This is greater than equal to 0. That is 0 is less than equal to this part. Now let us put the values whatever you are known with. If you go through, then you'll see this and last one will give me e, and these three things will give me g. And then you can take t common, t get cancel mod t, and that's it. The proof is constructive proof. If you do one and two times, then you'll get to know. So finally, what did we prove? We prove this. If you want to prove the function is differentiable, correct, you can do one thing. Try to find fx, try to find fy, and see whether they exist and they are continuous at that point. If this is true, then you will say that the function is differentiable at a1 a2, correct.